Okay. Hello everyone. So welcome. Okay, welcome. So first of all, this discussion, okay, will also be posted in YouTube as a public video so that everyone is visible. Okay. And free of course. All right. So for the part one, I'm going to discuss for task one. Task one. So you need to understand the structures of your KK lah. Okay. So your KK actually separable and linear is the one that you already cover in the syllabus. Okay. So these two already cover. So you have only one big problem, which is the one that is not yet been covered. For those that already been covered, you can just look at your reference book. Okay. Look at your reference book. And then when you put your reference, put the book itself. Okay, for example, Oxford Fajar. Okay, as a reference. Of course, for this one, it's a new one, right? Because it's a coursework, so of course you have to explore something new. Okay, basically you learn in university year one. Okay. Okay. We will look at how to define. Okay. And then task two, we try to solve some simple examples. Okay. Then we see how to solve the homogeneous. Okay. So I won't be going too much on the separable and linear. As later, I will tell you which one. Let's identify together which one is separable, which one is linear, which one is homogeneous, and why. Okay. And then for the linear and separable, you already learned the method. Or for some of you that you haven't learned yet, you will be going to learn in 1 month later. So you will be able to solve it. Okay. So I'm not too worried about some questions. Okay. And task three, also some examples, but a more challenging one is if you look at task two, for each of these differential equation, they only ask you to use one method to solve. Okay. But for task three, it's a solve the following differential equation at least using 2 different methods. Okay. So this is the time where it becomes more challenging. Okay. So I will be touching a little bit on this one. Maybe I will pick one example, one simple example to give you the idea of what does it mean by 2 different methods. I'm going to use an example that can be solving using linear, both linear and separable. The two that you already know, you already learned. Okay, so I won't be touching a example, okay, that solve using homogeneous and another method. That one will be covered in our part 2. Okay, there is one example among these 4. Okay, later I'm going to tell you. Okay, so task 4 is basically an application problem. Okay, it's a very classical application problem. It's what we call a mixing tank problem or mixing problem. Okay, you have a tank, you add some water in, you put some water out, inflow, outflow. What is the concentration? This is the general idea. Okay, if you notice that there is one past, this kind of setting is in one of your past year question. I don't remember which year already. I think 2018 or something. Like that. Okay, it was in a section B, 15-mark question. In the part A, I remember that they asked you to derive the differential equation for 5 marks. Okay, but today we are going to look at a more general problem. Okay, when inflow greater than outflow or less than the outflow, or when inflow equal to the outflow, what happened? So that are some core topic. Okay, so I'm going to focus on what should we do. Okay. Are you ready? First of all, I have to explain. My way of explaining, okay, is very, how I want to say, is very, I don't wish to give you all the detail. For example, if I want to define what is a homogeneous equation, homogeneous DE, differential equation, I'm not going to give you the full sentence, but I'm going to give you the key idea, because I don't want all of you that listen to this discussion going to write the same thing. Okay? If not, I'm the one that would be wanted by MPM. Okay? They wanted me. Okay, so I'm not going to do that. I'm going to write some very simple, and for the definition part, I actually will leave you all to explore yourself. What I'm more concerned is how to solve an example, okay? How to solve an example of homogeneous DE. So that's my main goal. All right, so let's start. So for separable and linear that perhaps you already study. So I hope that you understand. So I'm going a bit fast. I assume you already have some basic knowledge on separable DE. We're talking about first order, of course. Okay. First order. It's in the form of where you can have one side dx, another side dy. Okay. And one side function only depends on x, another side function only depends on y. This is the general form of the differential equations. Okay, an example lah. Okay, an example. Okay. If you don't like to write in this way, you can try to rearrange. You say, oh, teacher, why dx and dy can separate like this? So actually can. Okay. But normally for you as a beginner in differential equations, so normally you see dy dx equal to something else, correct? So normally that will happen to be mx over ny. If you notice that in your most of your textbook or your reference book, they also define in this way, meaning that you can have it is either a product or a fraction, quotient. One side only depends on x, another one only depends on y, and you can separate them. That's why we call separable. Okay, so this is the definition. I don't wish to write everything in full detail. So I'm just going to give you a very rough idea of what you expect to write. Okay, so this is the pattern. This is the definition. Okay, you can write yourself. Where you can write yourself. I just give you some simple idea because I know that you are very new to this one writing. You can say where mx is a function that depends on x only. Similarly, and y is a function that only depends on y only. You can say like that. Okay. So this is definition. Okay. This is an alternative form. You can provide. It's an alternative form. I'm not going to explain in too detail and you just need to define. So basically, your teacher also cover in the lab class. So I'm not going to further on that. Okay. So the second one, linear, you're also very familiar. Set linear first order. Linear first order DE. Okay. So we have a general pattern. I follow most of your reference book. Am I right? Okay. Or normally, if you don't call it P, okay, I will call it PX and QX. Okay. So basically, this is the general form. The bentuknya. Bentuknya dia kena ada. So that you can call this equation a linear first order differential equations. DE stand for differential equations. Okay. You can say P and Q are a function of X. Okay. So this is what we call linear. Just like that lah. Okay, nothing much to expect. Okay, so I hope that you understand. Okay, so far no question. So we may proceed to the the new thing that to you is a new thing, right? Which is called the homogeneous first order DE. Please write full name lah. Okay. Okay. So we are going to see how to define equation and DE that is homogeneous. Okay, so if you Google, okay, now I want to say something. If you Google, perhaps you will get some resources. Okay, that's good. If the resources is reliable, you can even cite in your references. But always remember the rule: do not cite Wikipedia. Okay, do not cite Wikipedia. Wikipedia is not a reliable source because anyone can edit on it. Okay. Even I can claim myself as a professional in differential equations and try to edit. If approved, everybody can see something what I wrote. Okay, so you better find some reference book. Okay. Don't worry, later I will suggest you 2 books, okay, that you can try to look at. Okay, so to make it simple as possible, actually, normally people have 2 ways to define homogeneous first order DE. It turns out that both are actually the same thing, but one more complicated. So I'm going to use the simpler version to you, okay? So if you can write your differential equation dy dx, okay? Okay, I would say simpler, but it also has some new notation for you, okay? For you now, you might be asking, what is f(x, y), right? Okay. But basically, the basic definition would require you to at least to write using this way, f(x, y). Okay, so for you, of course, you didn't learn this before. So I'm going to tell you that what is a f(x, y). When I put 2, f is like a function, yes. Okay, so it's a function. But instead of the function that you learn in your semester 1, chapter 1, this function is normally what we call a functions of 2 variables. That you're going to learn in calculus, university, maybe year 1 like that. Okay, so it's a function of 2 variables. Okay, you might not have many idea lah. Let's just give an example. Okay, let's just give an example, meaning that normally your fx only depends on x. So now imagine you can have some expression that depends on both x and y. Okay, so I just give you an example. Let's say x plus 1. It's a very simplest example of a function of 2 variables where you have 1 variable and the second variable in one expression. Okay, this is a very simple example. You can have other also, but I just give you one. Okay, somebody want to join. Let me just send this person a link. Okay. Wait, all right, let's continue. Okay. Okay. Okay, now, not yet finished. Not yet finished. This is not the whole story. Not yet finished. With one extra condition. Belum habis. Where it must satisfy some extra condition. For example, f lambda x lambda y equal to fxy. Okay, so this is the condition, the extra condition. So first, you need to be able to write your dy dx in terms of some other thing. That's first thing. And the second thing is that for this particular f, if you try to substitute your x with lambda x, y with lambda y, you will end up get back your fxy. Of course, now you won't understand what does it mean. So of course, I'm going to give you an example, okay, for you to understand what is happening. Okay, so if I have a differential equation that satisfies this condition, then I can call this differential equation as a homogeneous first order differential equation. That's the name of the DE. Okay. All right. So now let's look at some example. I'm not going to pick my, let's see, this one is okay lah, but I just give you some extra example lah, so that you won't be too boring with just one example. But you know something that, let's say, oh, for this part, you need to be able to define and also providing suitable example to say why this differential equation is a separable or is a linear or is a homogeneous. Okay, for separable and linear, I'm not going to give example lah. You can find many examples in your reference book. Okay, so I'm more focusing on something new to you that is homogeneous. Okay, let's give an example. dy dx equal to x squared plus y squared xy minus x squared. Let's say. Okay. All right. Now, it's not yet that you can say this equation is a homogeneous DE. Not yet, belum lagi. You have to check the condition to satisfy. Okay. So condition, let's check the condition. We check the condition. Okay, now, what is your fxy? Compared to this format, dy dx equal to the right-hand side is your fxy, which means that everything here will be your fxy. So this particular part is your fxy. Okay? Okay, never mind. Now we're going to see magic. Magic. Okay, magic is that I want to check whether this one, is it equal to this one, right? Okay, so I'm going to start with what is f lambda x and lambda y. If I want to show that it is a homogeneous DE, finally, I should get the answer to be fxy only. I need to be able to show that. Okay? Okay, so let's see why. Okay, now, what does it mean when I say f lambda x and lambda y? So look at the right-hand side here. It means that you substitute your x with lambda x. So here, and here, I'm going to replace with lambda x instead. And this part and this part, I'm going to replace with lambda y instead. Okay, you understand? So let's try to write them out. So it is a fractions, and then lambda x square. Remember, lambda x in the bracket square, plus in the bracket lambda y square. In the denominator, yellow color, green color means that lambda x multiply lambda y minus minus the lambda x squared. Okay. So far, this is what I have. Okay. My final goal is to simplify this until I get back my fxy. What is fxy? Which is, I hope that I can simplify this one to this one. Boleh ke tak? Can I do that? This is my question. So let's see. Okay, so let's see. So if you simplify, you're going to get lambda square x square plus lambda square y square over, remember, there is 2 lambda, so also it's a lambda square xy minus here lambda square x square. Okay. And if you notice that all terms, there is a lambda square multiply with it. So what we can do is, we can factor it out. Okay, we can factor it out. So if we factor this lambda square out, so I get both lambda square in numerator and denominator as a common factor. And I rewrite back what is left over inside. And finally, if I'm able to cut and cut, right? Cut and cut. And if you rewrite it one more time, you will notice that this final answer, final expressions is just what you have at the very beginning. Compare this one with your fxy. Is it looks exactly the same? Correct? So that's why I can say it's equal to fxy. Of course, I didn't know at the first that this one must equal to fxy. I'm going to check whether it is true or not. In this case, yes lah, because I choose my particular example. Okay. But in case that it is not, then maybe you can say why it is not. Okay. That is your own job. Maybe you can provide an example that is not homogeneous and why. Maybe you can provide an example that is not homogeneous and show why. That's your own job, okay? So coursework is always like that you are not necessarily that you must follow step by step. Of course, that you must do all the things that they ask you to do, but it's okay sometimes that you can do something extra. I did that before. Okay. Anyways, we believe that if your teacher is okay, good enough, normally they will give you A in KK. Okay. You can ask your senior also lah. I mean based on your senior in your school lah. Depends on the teachers. Most of the Form 6 teacher, I think it's okay, like maybe 90%. I won't say all lah, because I've seen some case that very how to say cari pasal lah. Okay, they just don't want to give you an A in your KK, even though it can help you to raise your grade. Okay, anyway, that's another story lah. Okay, so are you so far okay with this very simple example? I just want to make sure that every one of you can understand this basic example. Later we will go through one more example. Okay, boleh? Okay, actually there's one thing I forgot to write. Okay, this one, right? This one is a format. This one is the conditions. Here we assume that lambda is not equal to 0 lah. We can say for all lambda that's not equal to 0. Of course, lambda cannot equal to 0. If lambda is equal to 0, you are not able to cut lah. 0, 0, you can cut, cannot. So don't do that if lambda is 0. So assume lambda is not 0. That's just a very basic assumption. Okay. So now we have done our task 1. We have finished our task 1. Okay. We now already able to define all the differential equations and then to give some simple example. For the first 2, you do on your own. Okay. So now we jump to task 2 already, which is we're trying to solve. We're trying to solve this. But can I ask, I will ask one by one. Okay, what do you think is the type of the differential equation for 2a? Out of these 3, separable, linear, or homogeneous, which one do you think? If you say homogeneous, you are still new to it, not very sure. But can you tell whether it is a separable or linear? If you already learn. If not yet, then never mind. Okay. If not yet, probably you watch the recording back. No idea? Okay. I think most of you are still new to differential equation chapter. I assume that. Okay. So okay, so I just tell you okay. I just tell you the A is linear. I'm going to tell you B is separable. I don't give you the answer for D. You just identify on your own, very simple. But I'm going to tell you the C is a homogeneous. So like this, I hope that we don't need to cover A and B. Do we need? I don't think we need. Because I think it's not very difficult. Okay. So for this task 2, I'm just going to look at one example, which is task 2C. 2C only. Okay. So apart from that, maybe later we can look at some task 3 simple example. Okay. Okay, so I'm going to look at C. Oops. Okay, sorry. Okay, so now we have a differential equations. Of course, I already tell you the answer, which type it is, okay? But let's work through a very so you now only know how to define, but you not yet know how to solve. It's just like you know how to define a linear, but the method to solve is what we call integrating factor. Separable, of course, you separate, integrate together. That is very simple. Okay, so there is also a particular method to solve a homogeneous DE. Okay, and you can follow my step. Okay, so first of all, that of course we check, is this differential equation homogeneous? Yes or no? Why? Okay, some more, this differential equation, there's a boundary condition given or initial condition given. Okay, so later on you expect what's going to happen similar, like when you have a boundary condition for linear and separable, very similar. Conditions is always for you to find some constant. This is the purpose of the condition. Okay. Okay, so let's work on, sorry. Before I go to this example, I have something more to speak about on my this one, on my definition of homogeneous. Sorry, I think I have to say this first. Okay, I would say that this one is the simplest way to define a homogeneous first order DE. But requires you to do one thing, which is you find out the online resources that really use this way to define. This is a bit not popular method, but it's simple. So if you normally, if you do normal research online, okay, and then you ask, you find what is a homogeneous DE, most probably you're going to get something like this. They define in a different approach, okay? Define homogeneous DE in different way, different approach. Which is, first, they introduce what is called a homogeneous function. Homogeneous function of degree whatever lah, degree k, okay? Different approach, and then they continue to tell you what is a homogeneous differential equation. Then only they define what is homogeneous. Then only they define. If you search online about this one, okay, normally they have a pattern in this way. You can check correct or not. I'm not very sure about this one, but more or less like this. More or less like this. Okay. They start by introducing this one, and then somehow they tell you what is homogeneous function of degree k and what is a homogeneous DE. Another definition by using this kind of thing. So try to do it. Okay. Now you try to work out in this way. This is a bonus. It doesn't mean that you have to follow this. Of course, once I already give you this one, and I'm going to use this method for the rest of my discussion today. Okay. So I'm going to keep this one. This one is a bonus. For those of you who really want to do something different, maybe you can provide a different way of definition. So that's a bonus to you. Okay. But this one for most of you is already sufficient. All right, so we may continue. Any question? You can type in the chat box. Okay, we go back to this one. Okay, using my definition, later you'll find out where is the resources. I won't provide you. Okay, because I have my own resources, of course. Okay, so for the equation like this, okay, which satisfy the conditions, okay, so of course we first have to say check whether is it a homogeneous. Okay, so let's check whether is it a homo DE. Okay, so according to my method, if you remember just now, the pattern of the differential equation first is I hope to write my left-hand side only contains of dy dx. Everything move to the other side. Everything else, right-hand side. So I will pindah ini to the right-hand side. So become y cubed over x cubed plus xy squared. Okay. All right. So basically, this is your fxy. If you remember the pattern, the right-hand side is your fxy. Okay. So to check whether it is a homogeneous DE, so you find what is f lambda x, lambda y. So it basically means you substitute your y with lambda y and then power 3 over your x with lambda x power 3 plus your x with lambda x and then y with lambda y and then square, right? You can see, for the beginner, I hope it's better for you to have this. Right? I replace my x, which is these two part, with lambda x. And then I replace my y, numerator 1, denominator 1, with my lambda y. So here and here. So what should I get at the end? I should get back my fxy. So somehow you also have to cancel the lambda. Lambda power 3 in this case. So let's do that. Okay, so if you expand, you will see a lambda cube y cube over lambda cube x cube. Okay. And then here also you have 3 lambda, 1, 2, 3. Okay. So lambda cube x y squared. So now the process is more or less the same already. You just factorize the lambda 3 out, okay, and then cancel, okay. Or I can write in a more shortcut way lah. But you try to write more steps, okay. So finally it becomes xy cube over x cube plus xy square, which is our original fxy. Am I right? So okay, but you can say lah. Before you start, it's better that you say let lambda not equal to 0. Just a better starting. Okay. What is a lambda? Lambda is not a 0 number, whatever. Okay. So you have this property. So now you can call your differential equation as a homogeneous DE. Okay. Whatever lah. Let me just call this equation 1, okay? Let me just call this equation 1 my differential equation. Okay. So therefore, the differential equation number 1, or the original one, actually you better refer to the original one. Therefore, the differential equations, we just copy back this one. Is homogeneous. Okay. We are done. Not yet done. We now only classify the type of the differential equation. We're not yet getting a solution, not even a general solution or particular solution, not yet. Okay. We're now only able to classify. So now we need a method to solve. Just like how integrating factor, how separable integrate, that one. Okay, we have a specific method for this. Okay, so I'm just going to tell you lah. I'm just going to tell you what is the method. The method is very important, so you better write down. Let V equal to y over x. So this method is not new to you, which is just a substitution. It's a substitution. You learn substitution. After separable and linear, there is a short subtopic which talk about substitution to transform DE into either linear or separable. Okay. So here, a homogeneous differential equation that basically tells you what kind of substitution you can use. And that is called this one, V equal to y over x. Okay. As the substitution to help you to solve, okay? As a substitution. All right, always, if it's homogeneous, V equal to y over x. There is actually another bonus. Okay. Some book, they even define a homogeneous DE, not in this way, not in this way, I just write in a very short. Like this, where dy dx equal to another function f that depends on y over x. Okay, meaning that we are mean to say that the right hand side of the equation of the dE, when you write in this formula, okay, right hand side of equation number 1, okay, is only dependent of y over x. But that probably could be confusing to your level now. Okay, if you can understand, then that's good for you. Okay, but if you cannot, just use this way. Another natural way to. This one is more natural, but this one is easier to use. This one is natural. This one is easier. So I'm choosing the easier one to use. So you have 3 ways to define a homogeneous DE. Okay, but once you define, try to find out the resources. Okay. Okay, it's okay. Now we back to this question. Okay. So now I already told you the method you can use is called let v equal to y over x as substitution. Okay. So okay, let's see how to do. Okay, let me just copy back this differential equations. Okay, I just highlight my y only. Okay. Now, for those of you who not yet understand the key idea of substitution, now let me tell you now, which is if I now have a differential equation that is about x and y. This differential equation is about x and y, correct? Which means that this equation contains only y, x, okay? Got x, got y, and got dy, dx. Of course, this one independent, this one dependent, okay? So we wish to, by using the substitution to transform, by using substitution, okay, we want to transform to another differential equation that is about x. I don't want y already. X, I remain the same, but y, I replace with a new variable, which is now I call it v or u, whatever. Okay. Normally we use u or v. I don't remember. It's okay. Anything. Okay. So means that instead of using y, I don't want. I want a new variable that's called v. Okay. But x, okay, I remain the same. X, no problem, I remain the same. So meaning that all your y in this equation, you have to somehow substitute with other things. Replace it. Okay. So here, I already highlights the y to you, which means later I don't wish to see the y already. You have to use some way to replace y with what? Later I will tell you, don't worry. And then also dy dx, you don't want to see. Dy dx, even though it's one thing, one item, it's not a fraction, it's one item, but you don't wish to see dy dx. You hope to replace this one with another thing. I don't know what is it. I'm trying to find this. All right. So now let's look at how does this method is so useful. How does this substitution is so useful? Okay, that can help us to solve. Okay, so since we say v equal to y over x, but we cannot but we didn't see y over x in here, right? So we only see y. I hope to substitute y equal to what? So from this equation, I try to make my y as a subject, meaning that I bring my x over here. Okay. So from this equation, y equal to vx. Boleh? I'm putting green color, means that I want to substitute with this letter. Let me just call again this equation 1, this one equation 2. All right. Okay. Now, meaning that if I substitute number 2 into number 1, on my right-hand side, I'm going to get something cubed, x cubed plus x multiplied by something squared, where this something is my green color part, which is my vx, because I'm using this. Okay. I use highlight pen. So from equation 1, you can see that I'm replacing with this. Okay. X, no problem, remain it the same because I accept x in my new equations, no problem. But dy dx also, I have to replace with other things, so I cannot leave my dy dx as dy dx. So how to do that? So this one, I believe that most of you, I do not really sure, but from equation 2, that is from this equation, okay? Now think about this equation number 2, how to get dy dx from this equation. I got y on the left-hand side, so it will be really good if I differentiate with respect to x. So if I dx both sides, I would get dy dx on my left-hand side, and I'm going to see what is my right-hand side. Okay. So from equation 2, let's differentiate both sides. Differentiate both sides. Boleh, huh? I know my writing is a bit messy, but this one is just a general idea. Huh? It's not even the necessary process of solving. Okay. So if I differentiate my equation number 2, dy dx is now on the left-hand side, and then what is on my right-hand side? Be careful, because now I'm doing d dx. So if I differentiate vx together, it's a product. So I'm using product rule. Okay, so I'm using product rule here. So a very simple product rule. I wish you can figure it out the detail lah. Okay, the first one remain, the second one differentiate, x differentiate become 1. Because d dx. We differentiate become dv dx, not 1, but dv dx multiply by x remain the same. Okay, so rearrange, you're going to get v plus x dv dx. We normally write the smaller in front, the larger behind. Okay, so this one, what I'm doing here is basically tell you what you have to replace with for the yellow color part, dy dx. I'm going to replace it with v plus x dv dx. This one. Okay, so I put exactly the same thing on the left-hand side. Right? Okay, so now it's the time to simplify. We simplify everything, and you will see that, sorry, I substitute wrong. It should be a V, right? V, eh? Not Y, sorry. Okay. So now we try to simplify this and you will find out that this equation can be solved. I'm not sure, either using separable or linear. Depends on how wise you are. Okay. So let's see. Okay, let's do together. This one everybody can do. V cube x cube x cube. This one plus V ada dua, V square. X ada tiga, 1, 2, 3. Okay, because the square. So x cube. So this is V plus x dv dx. All right. Okay, next, I'm going to do this step also, which is, if you look at the fractions, both numerator and denominator, there is a x cube. So I can take out the common factor x cube. Numerator, no problem. But for the denominator, I take out an x cube. So I will left with 1 plus v squared. Am I right? So here, v plus x. Same lah. dv dx. So I can now cut the x cube and s cube. Okay. So now on my right hand side, I have v cube over 1 plus v squared. I'm not yet know what happening. Okay. But here is another v. Okay. Here, left hand side, there's another v. So this is just v. This is also just v. Why don't we put together and then simplify it? Okay. So I minus v from here. And let's see what is the simplify of these two. How to simplify it? Basically, you multiply by 1 plus v square, 1 plus v square, a fraction. 1. Okay. So what do you get is common denominator 1 plus v square. So you have a v cube minus v times 1 plus v square. I just write out the answer. V times this one. Remember that it is like a bracket. Okay. So minus v cube together with a negative also, don't forget. All right. No problem. So you simplify that, you can cut the v cube and v cube again. So you left with v over 1 plus v squared. And here is x dv dx. Looks nice. So what kind of method to solve this? Now, all of you know how to solve this already, right? Separable lah. Separable lah. Okay, we just try to work out this full example lah. We just try to work out this full example. For the rest of the test 2 is your own homework lah. Okay. I just try to help what I think that you might face most difficulty lah. Okay, so this one is already separable equations. So we use the method of separable lah. dv will remain here, dx we go to the other side. If you understand, good. Don't understand, never mind. Okay, so I put into the other side also because this is dv. So I put dv. I put everything v in my right hand side. Sorry, left. So I terbalik the fraction. I have 1 plus v square over v on the left. And then this x turns to the other side will become 1 over x also lah. Okay. Okay. And then the next step is that you are presenting you are presenting, wait, y not minus v. Is it minus v? Yes, it's a minus v. Thank you so much. So minus. Okay. So this minus, you can either put it here or you want to bring to other side, but normally I just leave it to the one that is simple. So I remain for the negative 1 over x. Okay. Okay. So next step, because you are presenting, so you better show the whatever word you just write lah. Like normally you don't even write this, but you can write this, right? Integrating both sides. Integrating both sides. 1 plus v square. Okay, so 1 plus v square over v, there's a common denominator. You can actually separate the term. This one term, this one another term. So what do you get? You're getting 1 over v plus v only lah. Correct. So dv here, and then integrate, negative I just put out, 1 over x dx. Okay. And use your knowledge that you already have in your integrations. So this is basically ln modulus v plus v square over 2 equal to negative ln x. Remember, we only do 1 plus c. For those of you who already know lah. So we only plus c on the right hand side lah, normally. Okay, 1 constant enough. Even though you do 2 integration, 1 constant only. Okay, because add up, c1 minus c2 is c. Okay, if you understand. Okay, so far we have get a solution. But the solution, I'm not really happy because this solution is in about v and x. Now, the purpose of transforming is just to solve only. But after solve, I don't wish to see again this v. So v is like an intermediate. It's act as a role of the intermediate variable. After I use the v, I want to tukar balik. Tukar balik jadi an equation that has connect y and x. So I change using substitution. So I also later, after solve, I change back to x and y. That's basically what we do lah. So don't forget to change back into x and y. So from where do you know you want to change back to x and y? You see here you have v. If you don't wish to see v, so what is your v? At the very, very beginning, we say v is equal to y over x. So this is where the substitution comes from. So now we substitute, we replace our v with y over x, so you can get back. Y over x square. Just give some color to you. Okay. And you can try to simplify this, but it's believe me that you're not able to put into y equal to fx form. Not able. Okay. Later on, when you do more and more questions, right? There's a certain normally we like our final answer to be in a y equal to fx form. Means that if you can put your y as a subject, that is the best case. But sometimes you are not able to do that. Not if no one in this world know how to do that. Make y in terms of fx. Okay. So in that case, it's okay. We leave our final answer just like that. For example, in this case, we just leave our final answer as this one plus this one you can simplify lah. Y square over 2x square equal to negative ln x plus c. Okay. Okay. I hope I didn't make any mistake lah, because I didn't check that. So I hope I didn't make any mistake lah. If I do, few of you here just help me to see whether I did any mistake. Okay. I think no, because I do very slow. Okay. So in this case, not able to do that lah. So in this case, we call this normally lah. You would call this as a general solution. General solution means your C is not yet a specific value. It means that with C, with the plus C lah, or whatever constant there. Okay, so we only done the first part. We still need a bit more. Normally in exam, there's another 2 marks to use the condition given to find out the value of C. That's the second part lah. Okay, so what do? Is you go back to your questions. The condition given is called y equal to 1 when x equal to 1. Okay, so what do? You substitute x equal to 1, y equal to 1 into the last equation you get. Let me just highlight with a different color. Okay, let's say we call this as equation 4, boleh? I think it's 4. Actually, I should call this as 3. If you want, you can say substitute 2 and 3 into 1 here. But that is not necessary in STPM. Okay. So now I'm calling this equation 4. Okay. So now I substitute y equal to 1, x equal to 1. That's a condition given. Okay. Into my equation 4. So what I'm getting? Ln 1 over 1 plus 1 square over 2 1 square equal to negative ln 1 plus c. What is your c? So this is 0. This is 0. So this is 1 over 2. So c is 1 over 2. Okay. Okay, so c is 1 over 2. Finally, we substitute back into equation 4. Okay, so we substitute back into equation 4. Whatever lah. 5. Okay, so substitute 5 into 4 lah. 5 into 4. Okay, so you're getting back. I'm just going to copy paste, but my c is equal to 1 over 2. So actually until here, I mean until this part, actually by the beginning, after you are able to determine the substitution format, so what to be substitute, everything is just what you have learned. It's just what you have learned, or what you should learn. And this is the final answer. At the same time, we also call this as a particular solution. Okay, that just now is a general solution with C. So particular solution is the one that you have a specific value of C. You already find out your C. Substitute C equal to something already. Okay. So your C already get. Okay. So that's an example of homogeneous differential equations. Okay. It's not that you simply come out with a substitution, but you able to identify it as a homogeneous DE, then always the method is going to be useful is this one. V equal to Y over X. And then do. Sampai, okay. After this part, just what you know lah, okay? And then do normally find general solution, particular solutions, as usual. Okay, I just want all of you to check that whether my working is correct. Huh? I hope there's no wrong. Okay, if yes, tell me please. Because later this is going to be a public video. Okay, so I'm done with task 2. Are you happy with that? Or do you still need me to discuss some other task 2? Probably no, right? Probably no. So can I just jump straight to task 3 a bit of a task 3 lah. So task 3, I'm just going to do one. Let me see. So A, B, D, I don't think you need my help lah. So that one you can try on your own. All right. Can check. Okay. Oh, yeah. Task 2, remember, you first have to state what is the kind of differential equation. So classify means you have to state whether it is out of the 3, which one it is. Okay, I already give you 3 answers. The last one you do on your own. Okay, very simple. Okay, I think with that, we can now move on to task 3 already. There's no specific thing in task 1 and task 2. Very easy. Okay. I just want to finish the discussion. Like I purposely make it into 2 parts because task 4 definitely will be part 2, and task 3 I hope that at least 1 or 2, at least 2 questions, and maybe I will put into the part 2. So for this one, I'm just going to show you just a simple one. Okay, can we just take a simple one to do? Okay, what I mean by a simple one is I'm thinking of B or D. If you look at this one, definitely some is easier, right? Some is easier, some is more difficult. So you have to solve using at least 2 different methods. So this one usually challenging. Okay. So you don't do this in your normal lecture also, right? In your normal class, your teacher just always just tell you, or if you see this one is a linear, do linear. If you see this one is a separable, do separable. But did she told you about that one differential equation at the same time it can be both linear and separable together? This is possible to happen. Of course, there is some certain equation that only can be linear, not separable, but there also some equation that can be both separable and linear. Okay, so that's the idea. So I just want to bring out one example that to let you see. Let's take this one as an example. Okay. Oh, why? Actually, task 4 is more complicated, right? I think at least 1 hour task 4. Maybe more than 1 hour. So maybe I can pick one question on C and do 2. Okay, let's look at part D. Let's look at 3D 3D. Okay, what does it mean by 2 method? Is that At the first moment, maybe you're still not able to see it, okay? Why two methods? At a very direct, they purposely write in this way so that you might think it is a linear differential equation, right? Why? Because you can rewrite as dv dt means that I multiply every term with 2t. So my 2t get rid of already. So this one negative t multiplied by 2t, I get negative 2t square v. T multiplied by 2t also 2t square. Okay. So the method one I'm going to show you is a linear method, linear differential equation or linear DE. Linear. Okay. So we just go through go through back what do you have a linear when you have a linear equations. All right. So it's natural. So you just need to compare. Just need to compare with the general form, which is you have a P. You can have PT or sometimes I don't even care. I just write like this. It's the simplest possible. Okay. So my P is this part. And my Q is this part. I don't even care what is my Q. I only care what is my P. Because that will involve in my integrating factor. Okay. So once you're able to put it into the general form means that dv dt in front here there's a coefficient 1. I don't want to have any other thing like this. Okay. Okay, so then we do like normal. IF for integrating factor, that's equal to the exponent to the integration of the P. In this case, not dx, it's dt. Okay, so you're going to integrate the P on the exponent. Okay, so let's see what you are going to get. So my P is negative 2t squared. So negative put outside lah. Okay, so if you integrate this one, you're going to get negative 3t cubed over 3. Correct. So I hope you already learned about this one. So this integration, we do not need to plus c, just this. So this is the so-called integrating factor. Okay. So next step, we call this as an equation 1, the general form, the general pattern, general formula. Okay. So we multiply equation 1 by the integrating factor. Just IF lah. Sometimes I just need to write IF. Okay. So what do you get? You can basically write each of them multiply by E negative 3, this one, no problem. Okay. Just write like this lah. For the left-hand side, it's a bit longer, but I just need to put what I have in minus 2t square V. Okay. Because multiply both sides, multiply it on both sides. So here you have a 2t square E negative t cubed over 3. So that's what I have. Okay. So I'm just going through the very general process. So everybody should assume the same thing to happen. Okay. You can follow your school teacher method or follow my method, whatever. Okay. So always your left hand side is going to be the d dt of the integrating factor multiplied by the v. In this case, so normally it's y, but in this case, it's your v. So v multiplied by the integrating factor, which is this. So if you're unfamiliar with this, then probably you have to go through back with the theory and with the example. You have to try more example before you try this. Okay? I haven't do anything. I just rewrite my left-hand side with this only. My right-hand side remains the same. I belum integrate. Now only I want to do. Up to here, I can say integrate both sides. Okay, integrate both sides. So integration d dt ve negative t cubed over 3 dt, that's equal to the integration of everything here, 2t square e negative t cubed over 3 t. Okay, so integration and differentiation will cancel each other because they are the reverse process of each other. So these all cancel. Okay, so on my left hand side, I only have VE, this one, which is V multiplied by the integrating factor. So on the right, you really have to do this integration out. Okay, so what kind of technique that you need? Okay, you have five techniques. U substitution, trigonometric substitution, integration by part, partial fractions, and trigonometric identities. 5 techniques. So among these 5, which one are you going to use for this? Okay. A natural guess is IBP because this is algebra, this is exponential. So a natural guess is like this. Okay. But when you do, you will find some difficulty. If you don't believe, we can try a bit. Okay. But of course, never mind, I just share some technique to you. So let's say if I try IBP, okay? Because I say that this part is the algebra A, and this part is the exponential part E. So by according to the ILATE rule, ILATE, my preference of differentiation will follow in this order. I have A and E because my A come first, so it's suggested that my U is equal to 2t squared and my V prime is equal to E negative 3 cubed over 3. I hope you understand what I'm saying here. Let's say this is the case. Would you find any difficulty? Let's see. For differentiation, definitely no question, no problem. You know how to differentiate. But for the integration, do you know how to do it? If you're going to tell me the answer is like this over negative 2t squared, wrong. Okay, wrong. You know why? I leave it for you to try to think on your own. Okay, why this one cannot? Okay, if you're my student, probably you can find the answer in my lecture note. Okay, apart from that, so basically we cannot do integration by part. Okay, you can't put a variable in the denominator. You can only put a constant. Means that if you differentiate the index, it is a constant. You put at the denominator, no problem. But if it contain t, that is the independent variable, no, don't do that. Okay, So this suggests that, this tells you that IBP is not a good method to work in this case. Okay. So probably that we have to try in another method. So this one I just copy, paste somewhere else, just for you, just to remind you that. Okay. Because this kind of integration is very popular even in your exam also. Okay. So just share some exam techniques. Okay. Okay, so now let's look back again on this integral. What should we use? Okay, the hint is actually here. This one, the index power 3, or the degree is 3, right? The power is 3. And what is below, means what is multiplied with the exponential, is of a degree 2. If this to this is 1 less, then you are able to use a U substitution. Normally, a U substitution will be helpful. And let U to equal to the index, which is this part. I'm referring to the index, it means what is on the exponent, the whole thing here. Okay, look at the power. If the power is 1 less, that suggests you can do differentiation to get that. So U substitution is a very good method. Okay, let us try lah. Let us try. Then only you understand what I'm writing. So let U equal to negative t cubed over 3. That is my index. Okay. And then du is equal to 3 cancel, right? So I have negative t squared dt. Okay, negative t squared dt. Okay, so what I'm going to do the next is you know what I'm going to do? If let's say I don't want to do one step directly, I will prefer to bring the 2 out, because the 2 now is confusing. So I put my, and then I put my t square and dt together. Like I want to substitute them together. This is my normal way on doing this. So later on, you understand very clear that the index letter will be replaced by U, and the one that is multiplied with the exponent E something, which is t squared dt, you're going to replace with one more step here. T squared dt is equal to negative du. So this one tells you what to substitute. That's why the hint is 1 less power. If you have power 3, differentiate, you get power 2. That you can do the power 2 together with a dt, substitute with du only. Okay, so let's write them out lah. So this is 2 EU negative du integration. Okay, so you do this integration, which is negative 2 EU du, and that is just the same thing, because EU integrate EU again, and plus C, don't forget about that. Okay, so because that you use a substitution U, so your final answer also better to change back into T lah, okay, into T. So your U is equal to negative 3 negative t cubed over 3 plus c. Okay. Okay, is there a final answer already? Not yet, of course. What is your, because your left-hand side is VE negative t cubed over 3, right? Yes. Okay. So, let me just take a look. Oh, okay. So this equation is V dependent variable. V is not a substitution. It's basically just the dependent variable. So I'm hoping that if I can let my final answer to write in the form of V equal to FT. The best one. The best answer. Best final answer. Just remember, if you can make your dependent variable in terms of all independent variable, then that is the best case, the best final answer. Okay. So E t cubed over 3 multiply with, are you okay with here? This one, when you bring over the other side, it becomes 1 over. But by using index rule, the negative exponent, negative become positive. So that's why here is a positive. Okay. So let's write one more time. The final answer should be, this one, when you multiply in, already cancel, because the exponent again by index rule, I skip some I skip some step. I do a shortcut. Probably you can do the full working. Okay. So here should be a -2. I normally prefer to put minus term behind. So CET cubed over 3 minus 2. That is the final answer. And in the form of FT. In this case, we only need a general solution because the question is not given any conditions. So yes, it's a final answer. Okay, quite spending a lot of time in just doing this one example. Okay, I hope you'll be enjoying trying and trying other questions. But I still haven't finished this example yet. As I say that, I want to show you that there are 2 workable methods. At least two. So this is one of it, linear. And normally linear is more complicated than a separable one. Let's see correct or not. So we spend almost 2 pages to do the final answer. Okay, especially the integration by part and use substitution. Let's see the other one, would it be better? Okay, let's see the other method, would it be better or not? Okay, so big. Okay, let's solve the same equations by using another method 2, separable. Okay. So why is it separable? If you want to say that it is a separable dE, so first of all, that you must write dV dt on one side only. I don't wish to see another term, plus or minus. I don't want. I move over here. So I get T plus TV, and this is 1 over 2T. Okay. Okay. Here your goal is different. You try to factor out, take the common factor out. Let's say I see both T and T for these 2 terms. I like to take out the T because I try to separate. This method is called separable. So you like to separate the variable. You don't wish to let them multiply, but T and V is not the same, so I separate it. Now, okay. So now I'm able to separate T and V. Even though it's 1 plus v, but 1 is considered nothing. So the whole thing is for v. This one is for t. This one is for t. Okay. So now it's already separable. Okay, it's already separable. Perhaps that maybe you can give a more, you put into the next step and then you say why is it separable? Because dv over 1 plus v, and then 2t, bring over here, you get 2t squared dt. Here you can say it is a separable. Why? Because if you're following from our very original definition, this is your mv dv and t dt, where your mv is 1 over 1 plus v lah. Your nv, your nt is this one. So you can see the pattern. But that is a relief from the definition itself lah. But normally you do, until here you just straight away integrate lah. Don't think so much normally. Okay. So let's try together whether we can get the same answer or not. Like just now, we should get the same answer like this one. We should get the same. So let's try. Let's integrate together. I just don't write the necessary step you add on your own. So here become ln 1 plus v. Here become 2t cubed over 3. Okay, and of course a plus c. Looks like my final answer is not going to be same. Why? Wait. Give me a moment. Negative here. So, okay. Never mind, I check back later. Let's see later. Let's identify together where did where did us did wrong. I mean, where did I did wrong? Okay. So E equal, sorry. If we, you know lah. So ln this one equal to this one, it means that the triangle is equal to E squared. Okay, both is convertible. So 1 plus v is equal to the exponent of 2t cubed over 3 plus c. Okay, so normally EC, I'm just going to call it A. Okay, I haven't explained in the class yet, but today it's a very intensive because you're going to submit your okay. So I leave down the some detail to be explained in future in my class, okay, in the lesson itself. Okay, so v is equal to this one minus 1. I'm getting a different answer now. I'm thinking why. Let's figure it out why. Let me check through the process. Where did I did wrong? Let me just double check. Okay. Minus 2t squared. So minus, oh, okay. I really see the problem here because I forgot the minus 2. My p is actually minus 2t squared. Okay, we have been doing so long. No one of you able to see. Okay, it's okay lah. Probably I think you're still new to this. 2. So 2 over here. I just add up I just add what should be changes lah. Okay, what should be changes. So if you multiply both sides by this integrating factor, I'm just going to put a big blue color to indicate the difference. So here and here. Okay. So here there's a 2. Okay, so here there is a 2 over here, and when you want to let your u equal to, that will become, there's a bit different over here lah. That will become 2 over 3. Okay. So when you do differentiation, you will get negative 2t squared. Yeah, negative 2t squared. Okay, so now I see that there's no need for me to bring out the 2. I can straight away integrate it directly. Okay, so here, let me just rewrite a bit. Okay, so the integration t, let me just put e 2t cubed over 3 multiplied by 2t squared dt, where 2t squared dt all together, I'm going to replace it by this particular part. Okay, so just now from negative 2t squared dt, negative bringer. So here I only have this one is equal to negative du. Okay, where this one replaced with u. Okay, so if that's the case, then everything will be simpler lah, simpler to solve. So eu d minus du integration. Okay, and that is equal to negative eu du. That's equal to negative eu plus c. That's equal to substitute back u. I get negative 2t cubed over 3 plus c. Okay. Here also there's a 2. Okay. So finally, again, I'm applying my index rule. So this one will give me a positive 2t squared over 3 multiply with negative e negative 2t cubed over 3 plus c. Again, first term I get a -1. I'm going to put it behind. The second term I'm going to get c multiplied by e2t cubed over 3. Okay. Okay. Yeah. So basically the same answer lah, like just now, right? So I'm thinking that this question is quite easy, but yeah lah, it takes some time. Take about half an hour to figure it out. So I wouldn't say that it's easier lah, but I should be very careful. Okay, but not very difficult. Okay, so CE positive 2t cubed over 3 minus 1, and if you compare to this final answer, the only difference is just at the alphabet only. But do you think that means they are different? One is C multiply, one is A multiply. Do you think that means the answer is different? Yes or no? Just answer yes or no. Do you think this answer and this answer is the same or not the same? Just yes or no. Yeah, it's basically the same lah. Because we say arbitrary constant means that we do not care about the alphabet we choose. You can choose C, A, B. Don't choose T, don't choose V lah. Any other alphabet is okay. But normally we choose C and A. Sometimes we even use C1, C2, no problem. Okay. As long as it is a constant, we just say it is an arbitrary constant. Okay. So in this case, both answer is the same. Okay. And this show you a case that where one differential equation you can solve with two different methods. And these both different methods that you already learned in your syllabus. But which one is faster is obvious. This one takes only 1 page to do, where this one takes 2 pages to do. So which one is easier? Okay. All right, we have already finished our part 3D. Okay, so 3B, you just do on your own, because 3B also, I think, would be very similar to this one. This one I'm going to put into the part 2 discussion, as it will be a bit longer, okay? But I can give you the idea of part C, and maybe you can try it in your home, okay? And then we will close our today discussion, okay? I just give you the idea only, that you can try on your own, okay? For 3C, I forgot to copy. What kind of, first question I want to ask, what kind of differential equation is this? Based on the 3 that we already learned. Do you think linear, separable, or homogeneous? No need to give me a reason why, just say. If you say it's linear, then try to put into the linear form. And if you say it is a separable, put into the separable form. And if you are not able to do so, that probably will be the homogeneous equations. Okay. Of course, when I see, I already know it's a homogeneous equation. Okay, by looking at the power, you can easily tell why. But I'm not going to repeat the process. So for these questions, method 1 that you can use what I have given to you at the first place, homogeneous DE. Okay, so method 1 is you use the homogeneous. Homogeneous method. First, write your dy dx in right hand side. Show it is a homogeneous, and then let v equal to y over x. The method is like that. It's by a substitution transformation. Okay, so that's called a method 1. You can check that this is not linear. How hard you try to put into linear form, you are not able to get it. Okay. Also, it's not separable. How hard you try, you are not able to separate them. You're not able to separate as a product of just depends on x and another just depends on y. How hard you try, not able. So not linear, not separable, but it's homogeneous, but that only gives us a method 1. So we come to method 2. You have to think about it. Okay, so any suggestion, I give you a hint that to field of view here. I give you a hint that this one actually you already learned before, which means you already learned. Okay, sorry. I mean in the syllabus, okay, when you are not able to solve as linear and not able to solve as separable, so you need to transform by a means of substitution, right? But homogeneous, it means that you let v equal to y over x. So this is the specific substitution. But we have many kind of substitutions. Apart from v equal to y over x, we still able to have other form of substitution. Okay, so that's give us some method too. So what other kind of substitution that could make this equation become simpler? So what is that? You can think about this. I can give you the hint, of course, okay, but you can try to find it out. Okay, so I just give you the hint. Okay, I just give you the hint. If you're able to guess it correctly, I just say you are correct. Okay, so the hint is that based on this power 3, sorry, we cannot see it really clearly. And based on this power 2, the relationship is like 3, 2, 1 less. A bit similar to the U substitution, where in U substitution, when I have something which is one more power than the other, so normally I let the higher power to become my substitution U or V. Okay, basically just this part only lah. Just this part only. Okay. So that give you an idea of continue. You continue on your own. So what kind of substitution that you are going to make? So based on your, I think I already spoiler 70%. So try to figure it out. Okay. And try to work out the method also. Not very difficult. So normally in your exam questions, okay, there will be given a specific substitution. It's not like integration that say by using a suitable substitution. No. In chapter 10, there are they will tell you what kind of substitution you have to use to solve it. So no problem. So in this coursework, basically you try to find out the substitution in your own. What kind of substitution you need to put to solve this nicely. Not only just one substitution, you can have 2 substitutions. More than 1, perhaps 3, 4, 5, I don't know. Okay, but we try to find the easy one. Okay, so yeah. Okay, so this is all for the C question C. Okay, that I can give you. Okay, so take a bit look on part A, but I'm not going to do it now. But I will do a part A on the next lesson, which is on the part 2, and also the task 4 in our part 2. Task 4 require you to, I think, to plot a graph. So probably we need some software. I don't know, like Excel or what. Okay. This one, yeah, we have to figure it out. What are the 2 methods? Okay. Okay. Last 10 minutes, I give it for a Q&A session. You want to ask anything? So far, what we have learned in today's discussion. Okay. Part 2 discussion will be on this Saturday morning, most probably. Okay. If nothing happen, I will remain as Saturday morning, 9 to 11. But that is a private one, so which means that only my students are available, or those of you who purchase. Okay. You can text me. You can text me 013-313-7333. Okay, that's my phone number. Okay, so there will be an early bird price before the end of May, because I know that some of your school teacher just given to you only. Okay, so you can contact me lah. Okay, so any else questions that you want to ask for all of you here? Are you okay? Today so far so good, or teruk sangat? You have to look back on the recording. Probably yes lah, because not even I haven't teach yet for this chapter. Okay, so some more you have something new to learn. Okay, so if there's no anything else, that I think we can end our today discussion here lah. Okay. You need any suggestion on introduction methodology? That one, I believe that you already have some experience on your SEM 1, right? So most probably it's going to happen the same. Okay. Try to you can use ChatGPT AI lah, but try to don't just depends on them lah. Just try to don't just depends on what they give. Okay, don't trust any resources, anybody. Not even AI. You not even need to trust me. Okay, if I say you follow my methods, okay, you can get a final answer. But if I say something wrong, okay, then GG lah. Okay, so this one you try to find it out. Okay. Oh, finally, I said that I can suggest you 2 books, right? So maybe for your references, okay, maybe you can look at these 2 books. I think it's quite good. Okay, so the first one is the book of by Denise G. Zil. I think that's her name lah. Okay. Differential equation lah. You go to search differential equation, or you just type ODE. And then another book is by Boyes. Okay, Boyes. And some other author, I don't remember. Okay. Both is about ODE, which means the book is very large. It's very tebal. Okay. So basically, this is some university level, international level reference book. Okay. That will be the best reference that you can have. Instead of using Wikipedia, ChatGPT, or online resources, even university lecture sometimes is okay, but it's difficult for you to get. So the best one is from university textbook, like what I stated here. Okay. You can try to find out where did my statement come out from. There. Try to find in original book. Okay. So because this is your own coursework, so I'll leave it all for you to write on your own and try on your own. Okay. My words, that's all, right? And so if really no questions, and we will see again in Saturday morning. Okay. And bye for all of you who watching the recording in YouTube. Okay, see you. Bye bye.